Coming up on Doctype, stand back because I know regular expressions and I'm going to teach them to you. Today we look at some special characters in regular expressions. Then Nick will add his colorful commentary on CSS color models. So equip your battle axe and cue up all your macros because it's time for Doctype. This episode of Doctype is brought to you by Site5 and GoDaddy.
I'm Nick Pettit.
And I'm Jim Hoskins.
And you're watching Doctype. Whether you're a designer that thinks JavaScript is a decaf latte,
or a developer who can't tell his margin from his padding, Doctype has the latest tips, tricks, and tools to help make you the emperor of the interwebs.
So we just got back from the UK and we are finally back in the studio.
Feels good.
It's good to be back. And we were up for a .NET award. We didn't quite make it, but thank you so much to everyone that got out there and voted for us. We really appreciate it.
And a couple of weeks ago, we did switch over to YouTube for posting our videos. So if you haven't yet, check us out at youtube.com/user/DoctypeTV and subscribe and maybe even give us some comments.
We are also over at facebook.com/Doctype. And if you haven't checked us out there, be sure to fan us or like us, as they say. We post a lot of bonus content on our YouTube channel and our Facebook fan page, and we'll continue to do so in the future. And we also try to interact with you guys as much as we can, so be sure to check it out.
So this week, I'm talking about regular expressions and telling you a little bit about some of the special characters that you can use.
And I'm going to be telling you all about color models in CSS. Let's check it out.
In episodes 31 and 32, we showed you how to use regular expressions to match strings in JavaScript. Now we're going to take a look at a few of the special characters that you can use to make your descriptions of your regular expressions a little more accurate. So let's take this very simple example here where we have the regular expression lip. You can see it's contained inside of the slashes to make it a regular expression. Now this particular expression will match all of these different strings, for instance lip, slip, lips, and slips, because anywhere that there is a lip in the string, this regular expression will match. Lip doesn't have to be the entire string, it just has to be contained within the string. But sometimes that's not what we want. For instance, we may only want to match strings where the beginning of the string starts with lip. So what we can do is use the special caret character that represents the beginning of our string. So if we change our regular expression to begin with the caret, we're now saying that our regular expression should only match if lip is at the beginning of the string. So in this case, now we have a caret at the beginning, it only matches for lip and lips. It'll not match for slip and slips because the caret excludes the beginning s in both of those other strings. So anytime that you want to make sure your expression begins with something, start your regular expression with a caret. Similarly, you may want to only match things if they're at the end of a string, and that's where the $sign character comes in. It's a lot like the caret, but it goes at the end of your expression, saying that this should match the end of our expression. So if we take a look at this example here, we have lip with the $sign at the end, saying that we should only match things that end with lip. So in this case, it only matches the lip string and slip because they both end with LIP. The lips and slips will not match because they end with an S, not the end of the string. Next we have character classes, which are special shortcut characters that represent a specific set of characters that you might want to match. The first one we're going to look at is /d, or I'm sorry, \d for numbers, and the \d represents the numerals 0 through 9. So for instance, if we have this expression here with the decimal character and then cows, it would match all of these strings. 2 cows, 0 cows. It would even match 14 cows, but you can see that in this case, it's only matching the 4 cows. It'll still match because we're not restricting it to being the beginning of the string with the caret, so it'll actually not match the 1, but it will match the 4 in 14. And of course, it will match nothing in the no cows string. Now we can change this up a little bit by putting a plus modifier after the \d special character, saying that we can match 1 or more decimal characters. So in this case, now both 1 and 4 in our 14 cows will match. Next we have the word character, special character, which is the \w, which represents characters that would represent part of a word. For instance, A through Z, both uppercase and lowercase, 0 through 9, and underscore. So this is great if you want to match a word but you don't know how long that word is or what it consists of. So for instance, in this expression, we're looking for my, space, and then one or more word characters. So for instance, we could match my shirt, my shoe, or my 411. And it really doesn't matter, it just allows us to match the next word. Next we have the space characters, which are the backslash lowercase s. And this matches a space, tab, or new line characters, really any sort of white space that you might want to match. So this is great if you're looking to maybe remove or ignore leading white space. So in this case, our expression is a caret to say the beginning of our string. And then we have the space character with a star, meaning that there is 0 or more space characters. And then we have the actual meat of our expression, in this case, foo. This is great if we really want to match things like foo, or foo with a space, or multiple spaces in front of it, or tabs. Now, it wouldn't match if there was a dash or any other character in front of foo that isn't a white space character. All of our special classes also have negative classes that correspond to them. For instance, the backslash capital S means any character that's not a white space, or not backslash lowercase s. Similarly, the uppercase W means non-word characters, and backslash D means non-decimal characters. Finally, we have some special characters that aren't part of the expression, but actually modifiers to the entire expression itself. So they actually go outside of the slashes right after the second slash. For instance, the lowercase I is the case-insensitive modifier. So if we take a look at our original expression here of lip, it'll match LIP all lowercase, but if we have any uppercase L's or P's in them, or I's, or any other mixed case, it will not match. We can modify this by adding a I after the end of the expression, saying it's case insensitive, and now it'll match lip no matter what case the letters are in. We also have the modifier for multi-line mode, which is M and goes after the second slash as well. And what this is for is our caret and dollar characters. Now I said before they always apply to the beginning and end of the string, but we can also modify them to say that they represent the beginning and end of a line of a multi-line string. So for instance, in this case where we have a caret, hello, and dollar sign, which would mean that hello is the entire string, if we take this multi-line string where we have this is line 1, a new line, hello, a new line, and line 3, that's 3 lines where the second line is hello. And if we try to match on that, we're not going to get anything because that expression is saying that hello should be the entire string. However, if we add the M modifier, saying it's a multi-line string, it'll now match because hello exists on its own line. So the caret and dollar sign now mean that it's the beginning and end of a line in the string and not necessarily the entire string. Finally, we have the third modifier, which is G for global. Now this isn't necessarily useful in matching, but in these cases where we're replacing something based on a regular expression, it can come in handy. So for instance, if we take this string ha 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 and do a replace with the regular expression HA, and here we're replacing the HA with 2 underscores, if we were to simply do that, we would actually only replace the first ha in the string. Now we probably want to replace all of them, and in order to do that, we just need to place the /G modifier at the end of our regular expression, meaning that we want to match ha globally in our regular expression. So in this case, it's matching all of our ha's even though the previous ones have already been matched, and now all of our ha's have been replaced by underscores. When we come back, Nick's going to tell us about CSS color models, but first, let's take a look at Site 5.
Whether you need shared hosting, a managed VPS, or managed dedicated hosting, Site 5 has you covered. Site 5 is really great because of their amazing customer satisfaction. Site 5's Backstage allows you to manage multiple users, domains, add-ons, and upgrades, and you can of course check the status of your server and your support tickets. Beyond their money-back guarantee and uptime guarantee, Site 5 even has a free migration service. Check them out at site5.com. If you use the discount code Doctype, you'll get 10% off a yearly shared hosting account. There are tons of hosting options out there, but none of them are quite like Site 5. CSS2 has a bunch of different color models, and there are even more in CSS3. This can be pretty confusing, so let's go ahead and see if we can sort this stuff out. Now, first up is hexadecimal color. This is the first color model I'm going to show you, and this is one of the most confusing, but fortunately it's probably one that you're most familiar with. But just in case you're not, let's go ahead and take a closer look. In hex, you count with the numbers 0 through 9 and then move on to the letters A through F. So in other words, it's a base 16 numbering system rather than a base 10 numbering system. Because we only have 10 digits to count with, we have to use letters for the remaining 6 digits. So the letter F in this example actually represents the number 15. Each of the 3 pairs of numbers represent a color. The first 2 are red, the second 2 are green, and the last 2 represent the color blue. The higher the value for each of the colors, the more that color is represented in the final result. So in this example, the red is maxed out, there's no green, and there's just a little bit of blue there. Actually, it's kind of like a mid-blue. And that will give you this nice fuchsia color. This green color is made with a very low red value, a maxed out green value, and no blue. And if a pair of values have the same 2 digits, such as FF9900, they can actually be shortened. We could instead say F9 and 0. This is a really handy technique that's faster to type and can clean up your code a little bit. In CSS2, you can also use what are called named colors. So, for example, if you just type the word navy instead of, say, a hex color, it will give you this nice navy color in the browser. Here's what typing yellow will give you. There are tons of named colors like this, but they're all predefined. To see a full list, you can just go to Google and type in CSS named colors. Named colors are really handy, especially when you're debugging and you want to highlight your divs in bright colors so you know how the page is flowing. They're really fast to type, they're readable in code, and they're pretty much universally supported. And finally, there's the RGB color model. If you're new to CSS or computer graphics in general, this is probably a bit easier for you to understand than hexadecimal color. The principle remains the same. You still mix red, green, and blue, but instead use a number between 0 and 255 to represent the color you're trying to pick. You simply type the word RGB for red, green, blue, and then you just put in your red value, your green value, and your blue value separated by commas. The higher each one of the values, the more that color will be represented in the final result, just like hexadecimal color. Here you can see the red value is maxed out at 255, so it's really pretty heavily represented in this orangish color. That about covers it for CSS2 color models. Next week we'll go into part 2 of this segment and check out colors in CSS3. Listen, you need a domain name. You know it, I know it, but where are you gonna go get it? GoDaddy, that's where. If you're looking to drive viewers to your video content, then .tv domains are where it's at. .tv domains are perfect for podcasters, video bloggers, and anyone with something to say. And they're available now at GoDaddy.com. Heck, where do you think we got Doctype.tv from? So we know you all get your domains from GoDaddy, but whose code are you gonna use? Enter the code Doctype3 when you check out and save an additional 10% off your entire order. Some restrictions apply, see site for details. Get your piece of the internet at GoDaddy.com. That's it for this week. Until next time, be sure to check us out at facebook.com/Doctype and follow @DoctypeTV on Twitter.
And if you have a question you'd like answered on a future episode of Doctype, send us an email at questions@doctype.tv.
And if you subscribe via iTunes or RSS or YouTube, you'll never miss an episode of Doctype. So come on, why not?
So until next Tuesday, remember that every great web page starts with Doctype.